Good morning, students. Today we'll be taking the second half of the chapter, that is conditions necessary for chemical reaction. In my previous video, I have already told you what is a chemical reaction and how does a reaction takes place. Characteristics of a chemical reaction. Now in this video, we'll be talking about what are the conditions that are required for a chemical reaction to take place. Okay, so in your book, there are various conditions given. So we'll take them one by one. The conditions are as follows. It can be through close contact, attraction in the physical state of reactants through solution. Third can be heat energy. Fourth is light energy. Fifth, electricity. Sixth, pressure. Seventh, catalyst. Now we'll take all these conditions one by one. First comes your close contact. The word itself means that if you want any chemical reaction to take place, okay, you need them to mix together. You need to mix them together. Okay, without coming in contact with each other, there can be no reaction taking place. Correct? Now, if you want to make food salty, you need to add salt to the mixture, to the food stuff. Until and unless salt is kept aside and a food mixture is kept one side. Okay? Even salt is just beside the food stuff, it cannot be termed as salty. The food stuff cannot be termed as salty until and unless you make them mix together, you make them come to close contact. That's why it is said that it is very important for two reactants to come in close contact to form a desired product. Here in front of you is a very good example of sodium when mixed with cold water. Okay, the reaction is very vigorous. It forms sodium hydroxide, NaOH. Okay, and hydrogen as a gas is liberated. Since this reaction is very explosive, when water comes in contact, explosion takes place. Okay, so this reaction shows that when sodium comes in contact with cold water only, then only it is explosive. Else you keep sodium aside and you keep water aside, no reactions will take place between them. Okay. Next is your attraction in the physical state of the reactants. Okay. Now what happens? In some cases, chemical reactions occurs when the substances are mixed in solution form. Sometimes you see two powdered substances are mixed together, but when we talk about mixtures mixed in solution form, what happens? This brings the reacting molecules in contact with each other at faster rate. You must have seen that generally medicines, if taken orally without diluting, takes time to get healed. But when you need instant relief, you are provided a solution form, right? Through veins you are injected or many more things, so that the reaction is faster and effective. So to make the reactions taking place more faster, you mix the solution in liquid form, right? You make a solution in liquid form. A very good example is given in your book, that is of sodium chloride. Sodium chloride is NaCl, okay? And silver nitrate. Silver is Ag, nitrate NO3, okay? So silver nitrate is AgNO3. Reacts with each other in aqueous solution. Now what is aqueous solution? Solution which is diluted in a bit of water, okay? Aqueous solution of sodium chloride and silver nitrate, both in liquid form you will take and you will mix together. Okay, what you will see, formation of silver chloride will take place. Ag will react with Cl and Na will react with nitrate. So AgCl, that means silver chloride will be formed and sodium nitrate will be formed. Now, silver chloride will be formed in the form of precipitate. I told you precipitation is a process in which uh, the insoluble part gets settled down at the bottom. So AgCl will be settled at the bottom in the form of precipitate. So first one we took them as in close contact. Second one is attraction in physical state. Third comes heat energy. It is very important. There are certain chemical reactions that takes place in the presence of heat only. Okay? If you don't provide them heat, there won't be any reaction change. Okay? A very good example is of iron powder. Okay? When iron powder and sulfur powder are mixed, they do not react better. Okay? Even they are mixed, they do not react. But as soon as you put or you provide them heat, they react and form a new substance, that is your iron sulfide. Fe stands for iron, S is for sulfur. When you react them, you mix them together in the form of powder and you provide heat to it, heat energy is given to it, it changes into iron sulfide, that is FeS. Okay, another example is given in your book that when you take lead nitrate, PbNO3 whole twice, and you heat it, okay, lead nitrate breaks into lead monoxide, PbO, and nitrogen dioxide, NO2, and oxygen is liberated. Third comes a very important condition that is necessary for chemical reaction is light energy sometimes. And a very good example is photosynthesis. That means photo means light, correct? And synthesis is to make. So photosynthesis is what? It is a process of making food in the presence of light by the plants. Now, some reactions takes place only in the presence of light. Such reactions are known as photochemical reactions. So, photosynthesis is a photochemical reaction. Why? Because in this food is prepared by the green plants in the presence of light. You can see in the slide carbon dioxide when reacts with water in the presence of sunlight and chlorophyll, it forms glucose and oxygen, C6H12O6 plus 6O2. Okay. Then in certain chemical reactions, electricity is also very important. So there are certain chemical reactions in which when you provide them electricity, then only the reactants break and they form the products. Okay. So here in the slide you can see the example of water. Okay. When electric current is passed through water, okay, what happens? It decomposes itself into H2 and O2. Okay, into hydrogen and oxygen. Clear? Now you know very well that water is a bad conductor of electricity. Pure water is a bad conductor of electricity. Okay, so what happens? For this to make it go faster, you need to add small amount of acid, salt or anything to promote electricity or to conduct electricity. So this process is also known as electrolysis of water. Electro means electrical use and lysis means breaking. So electrolysis means what? Breaking of any molecule in the presence of electricity. Next comes your pressure, condition that is necessary for some reactions to take place One of them is with the help of pressure. Okay. There are certain chemical reactions that takes place when reactants are subjected to have high pressure. Very good example is Haber's process. Haber's process is what? Formation of ammonia. Okay. In this, what happened? You take nitrogen from the air and you mix hydrogen along with nitrogen in the ratio of 1 is to 3. That means if you take one part of nitrogen, there should be third part of your hydrogen. Okay, and you make them react at 400 to 450 degrees centigrade, and pressure is also required, that is 200 atm, that means atmospheric pressure. And iron as a catalyst. Iron as a catalyst means what? It speeds up the reaction. Okay, and as a result, what happens? Ammonia, NH3, is formed. Clear? Then, last but very important topic is your catalyst. Okay, as in the previous slide, you must have seen that iron was a catalyst in Haber's process in the formation of ammonia. What actually is a catalyst? So the reaction says a catalyst is a substance that either beta increases or decreases the rate, the speed of a reaction without itself undergoing any chemical change during the reaction. That means it can either speed up a reaction or it can slow down the reaction. Okay? But when it is present in that particular reaction, it itself doesn't react. There is no change in the catalyst. It just speeds up or decreases the speed of a reaction. Okay. Now catalyst can be of two types, positive catalyst and negative catalyst. Now positive catalyst is what you can see. Positive means to increase, right? Positivity. So positive catalysts do what? They increase the speed of the reaction to take place. That means if any reaction is undergoing slowly, it speeds up the reaction. So you can have from your book, the example is given of potassium chlorate. Okay. In that, for breaking, MnO2, manganese dioxide, is mixed as a catalyst. Okay. What happens? It increases the speed of reaction, manganese dioxide, and it starts forming potassium chloride and oxygen. Very good example I have told you is iron as a catalyst in the previous video for making a previous slide for making ammonia. Correct? For making ammonia, you can see the reaction. This was iron as a catalyst. So this is a catalytic promoter. Okay. Positive catalyst can also be called as catalytic promoter. Okay. Now negative catalyst will be opposite of positive. That means it decreases the rate of reaction, the speed of reaction. Okay. Now this negative catalyst can also be known as inhibitors. Positive promoters and negative one will be known as inhibitors. Clear? Example can be phosphoric acid. Okay. Acts as a negative catalyst to decrease the rate of decomposition of hydrogen peroxide. Clear? Then, last but not the least, there are certain biochemical reactions. Now, till now we were talking about chemical reactions. Now, there are certain biochemical, that means biologically, the reactions that are taking place, chemical reactions that are taking place inside your body that provides you growth or provides you energy is known as biochemical reactions. Okay. Now inside your digestive system there are various enzymes that are working. Okay. Now enzymes are what? They are the protein that they are the protein catalyst for a biochemical reaction. Photochemical, light, biochemical, biologically. Okay. So they act as a catalyst.